So output is Taj Mahal, but whatever I said, the value of an object cannot be changed. Not changed. Where is changed? It is not changed. The link broken, new link created. Okay? Like this created. So first they'll ask, is it immutable or mutable? You will give answer immutable. Then they'll ask like this. How it is modified? They'll ask. Another object created, that hash code modified. So value of object we cannot change. Not possible to change. It is not changed. Another object created. Okay? Ready? In the above example, the value of object is not changed. Here, hash code changed. In the above example, the value of an object not changed. In the above example, the value of an object is not changed. Here, hash code changed. Is it over? See, in the above example, the value of an object cannot be changed. See, first line, one object created, that object referred by S1. Second line, one more object created, that object referred by S2. S1 dot concat S2, then another object created. This is not modified, but this link is broken, new link created. Here previously this hash code, now this hash code. Now, can we print Taj? Can we print Taj? Give me an answer. No, it is now garbage, unused object. You cannot access. Okay. Here, before line number 7, this hash code was there. Before line number 7, this hash code was there. When line number 7 executed, this hash code stored. So, in the above example, the value of an object is not changed. This Taj is not modified as Taj Mahal. Hash code changed. Okay. This link is broken, new link is created. Clear? Suppose this is only if you write with string buffer. Suppose it is SB1, SB2, if you write. Now, what is this? Taj is a which category of literal? String literal. String literal itself object. Which class object? But you cannot write to string buffer, no? It is which class object? If you write like this, error. Okay? It is string object, not string buffer object. If you write like this line only error. See? First line only error. String cannot be converted to string buffer. So that's what I'll do. I'll write like this. Now it is string buffer object. Okay. Now new string buffer. Like this you can write. Now a string buffer object created. In that object, Taj stored. Okay. That is referred by SB1. It is referred by SB2. Here, something SB1, SB2, SB1, if I write. Okay. Now, you'll get error. Reason, I'll explain. See. In that class, concat method not there in the string buffer class. Concat method is not there. There is another method, append. Okay. Now if I write, what will happen is here, if you write even here, string buffer SB3. Same like this with a string. First program I given. What is the output we got it here? Taj. Second one. Third one. Now you observe. First one also Taj Mahal comes. Reason that can be changed. Okay. Here. This here in first line. In first line. In first line, object created. This is string buffer object. This is SB1. SB1. Here, one more Mahal. This is string buffer object. It is referred by SB2. Now, SB1 dot append SB2. SB1 dot append SB2. This is appended. but it is actually here modified. Taj Mahal. Okay, here appended. This SB1 dot append SB2 means here only modified. If you print SB1, Taj Mahal, SB2, Mahal, SB3, it is result also SB3 referred. Now, SB3 also refers same object like this. That's what Taj Mahal you are getting. Now here Taj modified as Taj Mahal. Reason it is mutable. You can change. Immutable means we cannot change. Right, this one. Here, the value of object can be changed. That's what Taj modified as Taj Mahal. That is only referred by SB1, that is only referred by SB3. Second object as it is, Mahal, not changed. SB2 appended to SB1. That's what here changed. Which one? Yes. So Taj modified as Taj Mahal. But because here it is mutable, its value can be changed. In the above example, the value of an object is changed because it is mutable object. Because it is mutable object, that is immutable. Is it over? Which one is better? Which one is better? Based on situation, or string better or string buffer better? Buffer. Why? We can save memory. See, actually here depends upon situation. Okay. Sometimes string type required, sometimes string buffer type required. If you think about memory, string buffer is best. Okay. You can save memory. But now can you access can you print Taj? Can you print Taj? No. In that example, Taj also we can bring. Taj we can bring, Mahal we can bring, Taj Mahal we can bring. But here, Taj is not possible to print. Okay. Now Taj Mahal, Mahal, but you cannot print Taj. Now it's over. It is modified. So depends upon situation. Further, what will happen? Is you are going to see collections. At the time, two-dimensional collections will be there. Key value pair. Here, key value pairs will be there. Two-dimensional collections. Separate collections topic is at the time. Key value pair. Here, keys. Here, values. Suppose employee numbers, salaries, or employee names, salaries. Employee numbers, mobile numbers. Employee names, mobile numbers. Or employee names, mail IDs. Like that we'll write. Now, employee number. Are you going to change? Will you allow to change? No. That is, we should not allow to change. But salaries, maybe increments comes, decrements comes, something happen, no? Salaries increments comes. So you should allow to change. And mobile numbers, you may change. Mail IDs, you may change, like that. Key always mutable required. Immutable required. Value always mutable required. In that situation, immutable we use here, mutable we use here. That type will select. That is the reason these two concepts are there. Depends upon situation, we have to select. We should not allow to change employee numbers. We should not allow to change employee names. We should allow to change salaries. We should allow to change mobile numbers. We should allow to change mail IDs. Like that. Depends upon situation. Okay. Like that we'll select. Now, this is mutable, immutable concept. Here, you observe. This is immutable. This is mutable. String buffer, same like a string buffer. String builder, same like a string buffer only. But next one, not synchronized, synchronized, not synchronized. Now, synchronization. It is a mechanism that allows to access a shared resource It is a mechanism that allows to access a shared resource only one thread at a time. It is a mechanism that allows to access a shared resource only one thread at a time. Here, thread. A thread is a piece of code that executes independently. A thread is a piece of code that executes independently. A thread is a piece of code that executes independently. A thread is a piece of code that executes independently. But here, synchronization thread. This is actually separate topic is multi-threading and synchronization. At that time, you will get a more clarity. Present theoretically, just one example I'll explain. See, string class. Methods of string class not synchronized. Methods of string buffer class synchronized. Methods of string builder class not synchronized. That is first I'll show you. You observe. Java P, java.lang.string. Okay. Java P, java.lang.string buffer. Now you observe. In a buffer, you observe maximum methods are synchronized. See, maximum methods are synchronized keyword is there. Okay. See, synchronized. See, all synchronized. See, almost maximum methods are synchronized. Okay. Synchronized, here. String class. You observe, it is string class. Synchronized word is not there. See, string, java.lang.string. You observe, synchronized keyword is not there. Okay. Synchronized keyword is not there. It is string buffer. From here onwards, synchronized appears. See, synchronized. Almost maximum methods. Okay. Now, methods of string class are not synchronized. Methods of string buffer class are synchronized. Methods of string builder class not synchronized. String builder, if I open, synchronized keyword doesn't appear. See, there is no synchronized. Okay. First, what is synchronization? It is a mechanism that allows to access a shared resource only one thread at a time. What is thread? A thread is a piece of code that executes independently. This is all now little difficult to understand, but theoretically I'll explain. You can understand. Programmatically later I'll explain. Present, one example, 5 computers are there. Now 5 computers. Okay, 5 computers. 5 computers connected together as a one network. Now, printer. How many printers required? 5 printers or one printer? One printer enough, no? Because all connected together as a network. Then one printer enough. One printer. Now, no need of 5 printers. If individual is there, 5 printers required. Now, printer connected to this computer. Can I take printout from here? Yes. From here? Yes. From here? Yes. All computers can use the same printer. Now, printer is a one resource. Printer is a one resource. Can I call shared resource? Can I call shared resource? Yes. Printer connected to this computer, but it is not only for this. It is for common to all. So, it is a shared resource because all 5 computers can use the same printer connected to that computer, but it is shared by among all systems. So, all computers can use the same printer. Okay. Now, 5 members will click on print button at a time. All request comes to printer. Will it print all at a time or one by one? One by one. So, you will click at a time. It is allowing to click. At a time, all people can click because of multi-threading. All people can click. If it is single thread concept, one person only can click. That means always you have to check the printer. Printer busy or free. If it is free, then only can click. Otherwise, not possible. Because of multi-threading, 5 members can click at a time. Even printer busy also can click. Okay. Printer busy also you can click. All requests are received, stored somewhere. Okay. So 5 members can click at a time. All will click at a time. All requests comes, but it will allow one by one because of synchronization. Now it is one thread. 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 5 threads, 5 pieces of requests coming at a time because of multi-threading. It is allowing one by one because of synchronization. That is synchronization. Now, if many here, it is a mechanism that allows to access a shared resource only one thread at a time. At a time, one thread only can use. At a time, all cannot be used. Because of synchronization, one by one only allows. Some situation, one by one required. Some situation, all at a time required. Like that, so many situations are there. So many situations will be there. Suppose that example. In that printer is a shared resource. Printer is a shared resource, which allows one by one. Suppose google.com website is there. Google.com website. Can I call shared resource? Can I call shared resource? Yes. Google not only for you. Worldwide all people can use, no? It is shared resource. No. All people, they'll send the request to Google. Will it process all at a time or one by one? At a time. Those all requests are processed at a time. Suppose just assume there is a synchronization. What will happen? One by one means crores of requests coming to Google. You need to wait half an hour also. If it is one by one. Their synchronization not required. All at a time. Okay. Sometimes synchronization required. Sometimes synchronization not required. Here if synchronization is there, one by one, printer. Synchronization is not there. All people content printed on same paper. Then content is mixed. Then no one can understand that paper, that content. They'll throw in dustbin only. Wasted. They're one by one required. Okay. Like that, different application, different types required. Suppose you are going to book the movie ticket. You'll select one seat. But same seat may be selected by other person also. Okay. At the time, two requests comes to same seat. But will it allow at a time? If it is allowed, what will happen? Same seat allotted to both people. Then one by one required. Okay. But different seat is there at a time. Same seat is there one by one. Like that, code they'll write. That is synchronization required. Okay. Railway booking, movie ticket booking, air ticket booking, the online shopping. Suppose whenever sale comes, all people ready to book their items. Suppose that sale will start midnight, 12 o'clock. 12 o'clock only people will be ready, no? 11:50 only they'll start ready. But that items, only 10 items are there. Suppose. But thousands of people, they'll send the request. Then 10 people only will get it, no? There one by one only it will process. If all at a time processed, same item may be allotted to many people. But there is a quantity only 10 only. Okay, that type of problems comes. So sometimes synchronization required, sometimes synchronization not required. Situation. That type of programming, separate topic is there, multi-threading and synchronization. Now here, we are not going to do anything. Just one keyword will attach. Suppose this method is there. Now this method synchronized. If many requests comes to call this method, it allows one by one. String buffer class methods are all synchronized. String class many requests comes to access, it will allow all at a time. That's the difference. But here, you observe. Immutable, not synchronized. This is one combination. It is mutable, synchronized. It is mutable, not synchronized. But still one more combination missed. What is that? Immutable, synchronized. That concept not there. If required, they may introduce. Okay? That is not there. It is immutable, not synchronized. It is mutable, synchronized. It is mutable, not synchronized. But one more, immutable, synchronized, not there. If required, they may introduce. Not there, that is. Okay? This is the difference between string, string buffer, string builder. This is very depth. I'll cover further. It is theoretically explained now. Okay? Total, how many string related classes are there? 4. Now, 3 completed. These are nothing. Same methods are there. Next. String tokenizer. It allows an application to break a string into tokens. It allows an application to break a string into tokens. Tokens, nothing but words. It allows an application to break a string into tokens. It allows an application to break a string into tokens. Tokens, nothing but word. It also allows to count the number of words. In a given string. It also allows to count the number of tokens in a given string. See, if I write like this, is it one string or 3 strings? One string or 3 string? One string. It has 3 tokens, 3 words. Okay. Example. Welcome to Java is a one string and it has 3 tokens. Welcome to Java is a one string and it has 3 tokens. Welcome to Java is a one string and it has 3 tokens. Welcome to Java is a one string and it has 3 tokens. Is it over? No. If you want, suppose what I given see, it allows an application to break a string into tokens. This one you can break token by token. Welcome is a one word, to is a one word, Java is a one word. You can divide. It also allows to count the number of tokens. How many words are there? We can count. Here, no need to write any logic. Everything already prepared. Your duty only calling method, writing program. That's it. Okay. For that, methods are there. I'll give the methods. See, Java P, java.util.string tokenizer. This is just I'll copy to a file. Here, present whatever required, I'll give, remaining I'll delete. Constructors. Now, one constructor required, enough. Methods. 3 methods required. Enough. Now, your package name again and again is no, I'll remove. Java.util, I'll remove. Java.lang, I'll remove. Here java.lang, I'll remove. I'll give a description. Here, this is no need to explain. Consider what purpose to create object. Here, it returns true if the token is present. Otherwise, it returns false. It returns true if the token is present. Otherwise, it returns false. It returns current token and moves a cursor to next token. Note, it returns number of tokens. Token nothing but word. Over. C has more tokens. First, you complete. Welcome to Java. Now, first of all, cursor is here. If I call has more tokens, see what I given? It returns true if the token is present. Otherwise, it returns false. Now, it returns true or false? True. Okay. Cursor is here. If I call has more tokens, it returns true. It returns true if the token is present. Otherwise, it returns false. Suppose cursor is here. It returns true or false? True. Cursor is here. True. Cursor is here. False. Okay. Now, next token. It returns current token and moves the cursor to next token. Cursor is here. What it returns? Welcome. After that, cursor comes here. Again, if I call next token, 2. 2 return, cursor mode here. Again, if I call next token, Java return, cursor mode here. Okay. If I call count to tokens, it will returns number of tokens. How many are there? 3. That is. Now, cursor is here. First, I'll check has more tokens. True. Then next token. This is return. Cursor comes here. Again has more tokens. True. Next token. 2 return. Cursor comes here. Again has more tokens. True. Next token. Java return. Cursor comes here. Again has more tokens. False. Until you get false, you have to call next token, token. Has more token. These two methods repeatedly you have to call. Once false comes, you have to stop. Okay. So false comes, you have to stop. That means how to write? Loop required. Which loop? While loop or for loop or do while? While loop is the best option. Okay. For loop means again starting index, ending index like that required. Here nothing. Only true or false based. That's what while loop better. If you don't know number of iterations, while loop. If you know the number of iteration for loop, at least the body should be executed once, do while. Arrays and collections enhanced for loop. Like that you have to select. Now, count to these all methods. Which class methods? String tokenizer methods. Not string, no. Now, can I call with string class object? Can I call? No. You must call with string tokenizer object. See. First of all, suppose string s equal to welcome to Java. Now give me answer. With this s, can I call this method? With this s? No. It is a method of which class? String tokenizer class. It is a reference of which class? You cannot call. First, you have to create string tokenizer object. What we are write? String tokenizer st equal to new string tokenizer. Like this. You observe here. It is constructor. When constructor is whenever object is created. Which class object you have to create? String tokenizer. I created here. String tokenizer st equal to new string tokenizer. What is the parameter I passed? String s. S nothing but string. It is string only, no? I passed. But This class in which package? Java.util. Is it required to import? Yes. This class in which package? Lang. Is it required to import? No. Why? Implicitly imported. Now, import java.util.star. What is the meaning of star? All classes, all interfaces. Okay. See, here string tokenizer object created. For this class only, this line required. Okay. With this, can I call this method? Yes. What is the return type? Integer. What we have to write? What we have to write? Int one variable st dot count to tokens. Okay. System dot out dot println n. Now, here our task is counting number of words. Counting number of words is the required. Count to tokens method you have to call, but it is a method of string tokenizer class. For calling this method, this class object required. For creating object, this is required. For creating object, this one required. String also required. That is the reason. First string. That is I passed here. With that I called. Then printed. Now it will print. Welcome to Java. 3 words are there. Output will be 3. Compilation, execution. Now, program to count the number of words. Program to count the number of words in a given string. So count to tokens method I called to count the number of words. It will count the number of words. Over. We'll see continuation tomorrow. Okay.